Hi there, welcome to this video. We're going to talk about properties of integrals, and we're going to start calculating integrals with a graphical representation. So this is lesson 6 part 1, and we're going to talk about an integral here. They say interpret the integral from 0 to 4 of f of x dx, where f of x is this curve above. The integral from 0 to 4 of f of x dx, remember integrals are just area under the curve. So our interpretation here is going to be area under the curve. So we have the area under the curve f of x, and the numbers at the bottom of the integral symbol is where we start calculating the area under the curve, and the number at the top is where we end. Those are called our limits of integration. So from 0, x equals 0 to x equals 4, and then it is 7.5. So area under the curve is 7.5. We're going to use this knowledge in order to help us calculate integrals given graphs that are line segments containing rectangles, triangles, semicircles, so on and so forth. Okay, so here we have the graph of g of x is above. Find the following: the integral from -1 to 4 of g of x dx. Well, since I'm starting at -1 and I'm going to 4, that is going to be the area under this curve. And so this is a triangle. So I'm just going to calculate, this is going to be equal to the area of a triangle. So 1/2 base times height. Very important that you understand your simple area formulas. So 1/2 base times height is your area of a triangle. Our base in this case is 5, and our height, triangles are always measured vertically for height. So our height here is going to be 2. So what we end up getting is 5. The 1/2 and then the 2 will end up, oh sorry, not 2. That's a 3. That's a 3. I knew it felt unfamiliar. 15 over 2 is our answer, or 7.5. Okay? Number 2, I would actually like you to go ahead and try this one. So pause this one, try this example. Okay, hopefully you pause this one. For this one, again, 2 to 4. So here is your object, right? Area under the curve is just a triangle. So we have 1/2, your width is 2 and your height is 3. So in this case, your answer is going to be 3. Hopefully you got that, okay? All right, let's go ahead and look at number 3, the integral from 2 to 10 of g of x dx. Now, the good thing about this is I already found the area from 2 to 4. I know that that area is 3, and then I have this object, the area under this curve, from 4 to 10. So here's a property of integrals, is that you can split integrals. The area from 2 to 10 can be split from the integral from 2 to 4 of g of x dx, and then I'm going to add the integral from 4 to 10. These are the same thing. And so I do this because we already found, again, the area under the curve from 2 to 4. Now I just have this object. So this is a trapezoid, so you can go ahead and use a trapezoid formula. It looks like our height of this object is 2, and I have 2 different widths. I have this bottom width here, which is 6, and I have a top width, which is, I think, 3. Yeah, from 5 to 8, 3. And I have to average those, right? So I average those, okay? And that will give us our answer. So we get, what, 3 plus 9? Answer should be 12. Now, if you don't remember the trapezoid formula, which especially, you know, is weird, we've been working with trapezoidal rule, but these trapezoids are vertical where we have 2 different heights. If you forget that, you can break this into known geometric regions. Like I could draw a dashed line here, and then I have a triangle, and then I have a rectangle, and then I have another triangle right here. Okay, so you could do this, right? This area would be what? 1. This area is 6, and then this area right here is 2. So you can do that. College Board loves semicircles, and so here you can go ahead again, you can kind of see I have a triangle, you know, a rectangle, another triangle, and then I have a semicircle. So here they want us to go ahead and find the area from 0 to 4, okay? Again, and what I'm going to do is I'm going to break this, I want to break this into 2 geometric regions. I know that from 0 to 4, that is 6, right? The integral from just from 0 to 2 of h of x dx. I know that that's 6, right? 2 times 3 is our area, or you can count the rectangles. And then we have from 2 to 4, I'm going to go ahead and calculate that area, and that's a triangle. So I have 1/2, our width is 2 and our height is 3, so that's going to be a total area of 9. Okay, so 6 and then 3. Number two, they want the integral from -2 to 6 of h of x dx. So again, I'm going to kind of do the same thing here. I'm going to separate this. So this is going to be the integral from -2 to 0 of h of x dx. I got to calculate this area, which it looks like 1/2 times 2 times 3. Again, this will be an area of 3, right? 1/2, the base is 2. And my height is 3. So that's an area of 3. We already found this integral, right, from 0 to 4 of h of x dx. We said that that's 9. I'm just going to import that. I already have that. Okay, and then I have to go ahead and calculate the area from, running out of room here, from 4 to 6 of h of x dx, okay? And that's going to be this region right here, area under the curve here, okay? So this is a semicircle, right? Half of a circle, and so you need to know the area formula for a circle, which is pi r squared. And so for a semicircle, I'm just going to cut this in half, right? So this area would be half, and then what that region that I want, that's actually a quarter of a circle. It's a quarter of a circle. So I'm going to go ahead and I'm going to take 1/4 of the area of a circle, pi r squared. Now your radius is going to be the center, right? From the center to the edge. So the center of the circle is 6, and our radius would be 2. So pi times 2 squared, and that just ends up being pi. Now this is numerical, so if this was an FRQ question, you could stop here. Just know that that would be correct. But we can go ahead and keep calculating this. That's going to be 12, and that is just pi, because the 4 and the 1/4 will cancel. So 12 plus pi is what I got there. Okay, number 3. I want you guys to go ahead and try number 3. So go ahead, pause me, try number 3, and then we'll show the answer here in a second. Okay, hopefully you did number 3. This is the integral from 2 to 8. Okay, so again, I already know that the integral from 2 to 4, I know that that is 3. And then the integral from 4 to 8 of h of x dx, that's a semicircle, so 1/2 pi r squared, which is 2 squared. So that's going to end up being, I think, 2 pi. Yeah, 2 pi. So 3 plus 2 pi. Did you get it? Okay. Last topic for today is just these ideas of calculating area under curve with known geometric regions, but using a function involving an integral defined by another function. So g of x is the integral from 1 to x of f of t dt. Note the change in variables. In mathematics, we'll do this. If I have one function defined one variable, the secondary function, I'll just change the independent variable. Not a big deal. But g of 2, I'm going to go ahead and calculate this. Again, if I want to evaluate g at 2, I just plug it in. So this is the integral from 1 to 2 of f of t dt. So that's the area under the curve up here, okay? And so 1 to 2 is right here. So the area under this curve, that's going to be 1/2. Okay, 1/2 times 1 with the height of 1. So 1/2, 0.5. Number 2, g of 6. G of 6, this is the integral from 1 to 6 of f of t dt. Okay, and so here I have another triangle, but this triangle is below the x-axis, so this is going to be a negative area. So I have 1/2. I have 1/2 plus. Okay, this is a triangle, so 1/2 with a width of 4 and a height of -2, and really that negative height, right, we'll take care of that negative, or you could just keep everything positive and just know that it's going to be a negative area. And so that gives us 4. So we end up getting 1/2 plus 4, which is the same thing as 1/2 plus 8. No, it should be minus 4. Minus 8 over 2, which is -7/2. -7/2. Okay, last topic for today, a kind of new thing is number 3, g of 1. This is going to be the integral from 1 to 1 of f of t dt. And this is a property of integrals. Whenever your limits of integration or your bounds are exactly the same, your answer is going to be 0. And you might be asking yourself, why? Well, why? Well, we do area under the curve, and if I'm going from 1 to 1, I don't have any width. My width is 0. So if I'm multiplying by 0, right, to find area, area under the curve is going to be 0. So 0 for that one. Okay, number 4. Go ahead and maybe write this too. This is an important property, I guess. The integral from a to a of f of t dt equals 0. So if those are ever the same, it's 0. Number 4. Go ahead. I want you guys to find what is g of 8. Pause me, and then we'll check the answer here. Okay, g of 8, that's going to be the integral from 1 to 8 of f of t dt. We already have calculated the integral from 1 to 6, and we know that that is -7/2. So I just imported that, and then we have to calculate the area under the curve from 6 to 8. So again, that's a quarter circle, so 1/4 pi r squared. You have a radius of 2. Gives you -7/2 plus pi. All right, hopefully in this video you learned some properties of integrals and how to find areas in the curve using known geometric area formulas. Okay, give this video a thumbs up. I'll see you in the next video where we talk about some more properties of integrals.